Simplifying radicals. Remember, a radical tells us to take the square root. Basically, it's like this check mark looking thing here. So what we're going to work on in this lesson is how to simplify radicals, because remember, unless it's a perfect square, you're going to get an irrational number, a decimal that goes on forever, on and on forever without terminating or repeating. We have a couple properties here, and I am not concerned that you know the names of these properties. I'm more concerned that you know how to use them. The product property of radicals says that basically if we have the square root of a number like AB, A times B, we can break it up into the square root of A times the square root of B. The quotient property of radicals is similar. If we have the square root of A over B, we can break that up into the square root of A over the square root of B. So basically, we could say if we had the square root of 50, that's the same thing as saying the square root of 5 times the square root of 10, because 5 times 10 is 50. For our quotient property, if we had the square root of 2 over 3, that's the same thing as saying the square root of 2 over the square root of 3. Okay, and those might not be the best examples, but that's kind of what they mean. The simplest form down here is what we're going to be working on today. Here's how we know a radical is in simplest form. No perfect squares other than 1 are in the radicand. Okay, radicand just means under the square root symbol, under the radical. Our perfect squares, remember, 1, but it says 1 doesn't count right here. 4, 9, 16, 25, 36, 49, so on and so forth. Okay, so there's no perfect square factors. There's no fractions in the radicand. So basically you can't have a fraction underneath the radical sign. And no radicals appear in the denominator. So we could not have a radical in the denominator for it to be in simplest form. It says the process of eliminating a radical from the denominator by multiplying the radical expression by appropriate value of 1, I'll tell you what that means later, is called rationalizing the denominator. And we'll work on how we rationalize the denominator. But let's focus on these first two right here for simplifying. So simplify the expression 147. Simplify the expression 147. Well, basically, you look for perfect square factors that go into 147. So our perfect square factors, again, 4, 9, 16, let's not forget 25, 36, 49, 8 times 8 is 64, 9 times 9 is 81, 100, 121, 144. Now you could keep going, but I usually stop after 12. And what I'm going to do is I'm going to look and see if any of these numbers go into 147. And you want to kind of start with the high ones. 100's not going to go into 147. 81's not going to go into 147. Let's try 64. And I literally just take my calculator and I divide. If I divide by 64, I get a decimal. So 147 divided by 49, I get 3. So what that means is I can take the square root of 147. Okay, sorry about that interruption. What I was saying though is we can break down 147 into the square root of 49 times 3. We don't just want to take any factor of 147. We only want to try the perfect square factors, and here's the reason why. According to that property that we had on the first slide, we can break this up into the square root of 49 times the square root of 3. Here's why we want perfect square factors. What is the square root of 49? 7. And let's look at the square root of 3. Besides 1, does 3 have any perfect square factors? No. And so we leave it as the square root of 3. So in simplest form, 7 times the square root of 3. That's right here. No perfect square factors other than 1 in the radicand. And we pulled out the perfect square factor of 49. Let's look at some more examples. Simplify the expression, the square root of 98. Again, I am going to use our list here of perfect squares. And I'm going to just look for ones that go into 98. Always start with the higher ones. You can start with the smaller ones, but you might have to pull out perfect squares more than once. So if I just grab a calculator and start dividing maybe by 64, which doesn't work, 98 divided by 49, which works, we can write the square root of 98 as the square root of 49 times 2, because 49 times 2 is 98. Then we can break that up into the square root of 49 times the square root of 2. The square root of 49 is 7. 2 does not have any other perfect square factors besides 1. So our answer is 7 times the square root of 2. Again, I know you're like, why do we have to do that? That's just a rule for simplifying. Because this is an irrational number, because it goes on and on forever without terminating or out repeating, this is the way we can write it in simplest form. Let's look at the square root of 300. I know that 100 is going to go into 300 3 times, so I can break that up into the square root of 100 times 3. Again, 50 would go in there, or 2 would go in there, but we're only looking for perfect square factors. Then I can break that down into the square root of 100 times the square root of 3. The square root of 100 is 10, and 3 has no perfect square factors. So that, again, is how we simplify radical expressions. Now we're going to deal with a fraction under the radical sign. Remember, we had a property, whatever the name of that property was, that said we can break it up then and take the square root of both the top and the bottom. It's not good enough to go there though, because remember, we can't have a square root in the denominator. So let's take these two individually. If we have our perfect square factors here, let's just look at the square root of 27. Do any of our perfect squares go into 27? 9 does. So I can break the square root of 27 into the square root of 9 times 3, which is the square root of 9 times the square root of 3, which is 3 square roots of 3. Now let's look at the square root of 48. Does 48 have any perfect square factors? Now in this case, guys, you definitely could use 4, but you're going to want to use 16. If you used 4, well, let me show you with 4. If I did 48 divided by 4, I would get the square root of 12. So I'd have the square root of 4 times the square root of 12. So I'd have 2 square roots of 12. The problem is 4 goes into 12 again. So I would write 2 times the square root of 4 times the square root of 3, because 4 times 3 is 12. And then I end up with 2 times the square root of 3, or 4 square roots of 3. Absolutely nothing wrong with that. But watch what happens if I start with 16. If I go 48 and divide it by 16, I get 3. So the square root of 48 breaks down into the square root of 16 times the square root of 3. The square root of 16 is 4 times our square root of 3. Notice we get the same answer either way. This is just a lot shorter when you pull out the biggest perfect square factors. Okay, so let's see what we're going to do from here. We know that the square root of 27 is the same thing as saying 3 times the square root of 3. We know the square root of 48 is the same thing as saying 4 times the square root of 3. Square root of 3 on top, square root of 3 on the bottom, they're going to divide each other out, and we're going to be left with 3/4. Again, that's way simpler to look at and understand than this is. A few more examples. Simplify the expression. The square root of 1 over 100. Remember, we cannot have a fraction under the radical sign, so I break it down to the square root of 1 over the square root of 100. Well, what is the square root of 1? 1. And what is the square root of 100? 10. Simple as that in that case. Same thing here. We can break that down to the square root of 8 over the square root of 16. Does 8 have any perfect square factors? Yeah, 4. So we have the square root of 4 times the square root of 2. Again, 4 times 2 is 8. And what is the square root of 16? What number times itself equals 16? 4. So if we keep simplifying this, the square root of 4 is 2. And again, once I take that square root, I drop the radical sign. I have 2 square roots of 2, 2 square roots of 2 over 4. But if you look right here, 2 goes into itself 1 time, 2 goes into 4 2 times. We could simplify it even further. And this ends up being 1 square root of 2 over 2. Again, simplest form because there's a radical in the fraction, but there's not a fraction under the radical. That makes it okay. And there's no radical sign in the denominator.